to the first in a new video series on Project Data Science news. In this video series, we'll be taking a slightly deeper dive into some of the news items we discussed at the London Project Data Analytics meetup. For more information on the meetup, to look at past events and check out future events, then please visit our Skills Matter page, which I'll link in the description. Today, I'll be talking about some of the February Power BI updates and also giving you an overview on a recent bit of work I did classifying new projects, their RAG ratings, using various machine learning techniques. Stay tuned. So let's jump straight in and look at the key influencers visualization for the February Power BI update. Now this is a preview feature, so you do have to go to File, go Options and Settings, to Options, wait for it to load, and then you do have to select Preview Features and then make sure that the key influencers visual is selected. Okay, you want to click OK, mine is already selected, and then you need to restart your Power BI desktop, and then you'll have your visual here will always be available. So this is the key influencers visual, and this is what it looks like. And I've actually just dropped some NSAT feedback data in there, and then the explain by section is anything that you think might affect that feedback score. So we've got manufacturer, color, country, class, the cost, and you can see you can select your feedback score here 1. So we've got low feedback, and you can see that the sale size, if it's large, then the likelihood of this feedback score being 1 is increased by 4.32 times if this size is large. And then for a bit of a breakdown of what medium and small does, you can look at the chart on the right as well. So a really, really powerful visualization for seeing some what actually affects these different metrics. And again, if we set the feedback score to be high now, so I've set it at the top at 7, then the manufacturer is the biggest influencer here. So as if the manufacturer is actually litware, then the likelihood of the feedback score being 7 is 2.64 times as likely. And then again, we've got the breakdown of all these different manufacturers. And if we go and select the color is brown, so it's slightly less than the manufacturer, again, we have the breakdown. And then if we continue down this list, we can see all of the different metrics here and what influence they are. Back in the February London Project Data Analytics meetup, I spoke about this article on automating project management with deep learning. And I thought it would make quite an interesting read. And when I got time, I thought, I'll actually do some of my own investigation. Now, they've used deep learning, and I have moved on and had a look at some neural networks and some transfer learning. But to start off with, I thought it would make sense to actually look at some supervised machine learning and see what kind of results we can get using some more traditional methods. So it's worth mentioning that I used different data than the data they used in the article. I used government major project portfolio data from the UK using, and this contains from all different departments really, from the MOD to HMRC. So there isn't masses of data. I took all the data from the last 5 years, but I think one of the main restrictions and obstacles that I've really got is the fact that we have a significant lack of data. So if anybody can think of decent data sources, labeled data that we can use, then please contact us or write in the comments below, because if we can start web scraping that and collecting that, then we might be able to bump some of these accuracies up, which would be great. So it's probably of no surprise to you that I started off with a naive Bayes. Obviously, I've done some pre-processing of the data, and I've got a test size of 0.4%, and the model performed relatively well at just under 55% accurate. So I was relatively happy with that. But if you consider that I've compressed the RAGs from 5 because the GMPP, they use they use amber red and they use amber green as well, so they actually have 5 classifications. I've actually compressed those into just the standard red, amber, green. Then if it performed completely randomly, then we'll be kind of we're trying to beat a third. That's the baseline, really. So I moved on to a logistic regression model, and this performed significantly better, at nearly 70% accurate. And then finally, you probably guessed, but I use support vector machine, and this was actually the best performing model, just tipping 75% accurate. So I thought it was really interesting to compare these 3 models against each other. If I had to guess, I would have thought support vector machine would have outperformed the other 2, but it's interesting to test it. And now in the next video, we'll compare these supervised machine learning methods to some neural networks and some transfer learning.